Project title is Distributing Industrial Optimization Tasks to Rural Workers. Here we have developed the 2D and 3D packing software. The project aim is to investigate if it is economical and technical feasible for industrial optimization tasks to be outsourced to rural BPO workers. The objective of the project is to determine the capability of a rural worker in India and UK to do 2D and 3D geometrical reasoning, and to establish the competitive as well as approach to give the effective and economical tasks can be implemented within BPO and KPO facilities. This is the objective, and to quantify the potential economic beneficiary for both manufacturing industry and rural worker in India as well as UK. Our industrial partner is HIE, Safe Space, EPSRC, Department of Science and Technology, Geometrical, Rural Source, and Simply Grameen. We have conducted the different data sets of 2D and 3D packing trials in India across different parts. You can see in a map we have conducted the trials according to geographical condition of India in different locations in India with different background of rural workers. There is some snapshot while taking the test and trial of 2D packing trials. This is our interface which we have developed in IIITA. This is online geometrical reasoning test where you can see the interface. While typing the name and email ID, you can directly log in a page, and this interface will show you a package of taking the 2D packing test. While starting the 2D packing test, we are giving the training of 2D geometrical reasoning task. What is geometrical reasoning? We are taking the set of test. This is the 2D packing assessment. We will go on instruction page and we will read the instructions carefully, how to pack the item or objects in a bin in an optimized manner. There is an option that there is no collision in between the object. If there is a collision, the color will be changed while black in color. There is a button which we can use for rotating the object, shifting the object with the manual method. We have developed the manual as well as semi-hybrid approach. First we will start the 2D packing assessment with manual test. This data set, for example, we have taken the real data sets for trials. First we will start with the Albano test. The Albano is started with a manual test. In a manual, the person will fill all the objects in a bin, in a single bin. In a bin, all the objects should be packed in an optimized manner. The time is running out. There is a control button which will show on the upper side of the interface, and the time is shown on a bin uppercase. You can see that there's a bin, and in the below there's an object. We have to fill all the objects. There's 24 objects. We have to fill 24 objects in a bin. Then it will be checked as there's a complete assessment. There is showing that the length what we have used while packing these objects, and the efficiency will be shown while packing these objects. If there is a collision, the color will be changed. There is no collision in between the objects. It will be highly packed. The time is running out. It will be shown 58, 59, and the object is placed while using the keyboard as well as mouse button. While using the length, the efficiency will be changed. So we have to pack all the item in a manner so that the efficiency will be high. This is the industrial real data which we have used for packing the 2D task. We can finish and we can see that for a small movement we have completed 2D manual packing task. Now we will start with the hybrid task. In this, the computer will be packed the objects in a bin, and we have to just see and we have to minimize the gap, and we can achieve the higher efficiency with lesser time. The control button are the same what we have used in the manual packing task. This we can see that the computer can pack with some algorithm used, and the computer is packed the objects in a bin. All objects are packed, and we have to see that where is the gap, and we can minimize the gap, and where is the overlap in between the objects. We can minimize these overlapping, and we can achieve the higher efficiency with lesser time. You can see that the objects is moved by the arrow button left and right, and the gap is minimized, and we can achieve the higher efficiency by lesser time. This will be the real data which we can save the cost as well as we can save the time. In the right corner, the length is used, and it can be seen there is a 3 object which can be placed if the minimum space can be utilized, so that the higher efficiency will be achieved. This rotation button we can use with the R and shift R, anti-clockwise and clockwise. There is a button in a keyboard R for the rotation of the objects. We can finish the button, and we can achieve the efficiency 68.98% within 115 seconds to pack all the objects in a bin. This is about the 2D packing software which we have developed. If you have any query, or please feel to contact with us. You can subscribe our video to YouTube by clicking on a subscribe button. Thanks a lot for watching this video.